In this movie, you learn how to create a low polygon building using simple extrusions and proper textures and mapping. The workflow you learn is meant to keep the face count to a bare minimum and relying instead on textures to give the illusion of realism. This is important when you plan to have dozens or even hundreds of buildings in a scene. 3ds Max, of course, has the tools to build detailed geometry, but that's not what we are interested in here. Case in point, take a look at these two facades in the file named low versus high.max. From a distance, they look nearly identical, both in the viewport and at render time. Close by, you can see the differences, mainly the positive and negative volumes around the various architectural elements. Obviously, the facade on the left is more detailed, and you can verify this by switching to wireframe mode or edge faces mode, F3 or F4. By checking the object properties, you can see that the facade on the left has as many as 1163 polygons, whereas the facade on the right has only 5. As mentioned before, this becomes significant when you have a high number of buildings in a scene. Keep in mind that when viewed from a distance, the difference at render time is not very pronounced. If the camera gets close to a particular building, then you can always add detail to that specific one. And so, in this movie, we focus on low polygon building creation. Open the file named cityblocks-building-start.max. This picks up where the last installment left off, namely with 3 city blocks and urban design components in place. In fact, to make the scene easier to work with, press H and then type UDC to select all the urban design components in the scene. Press OK to confirm the selection. Create a new selection set by naming it UDC. Remember to press Enter to confirm the selection set creation. Hide the selected objects so they don't affect viewport performance. Make sure the perspective view is maximized so you have a better view at the building lots. The workflow you'll be using is based on extruded 2D splines. That's arguably the easiest way to create building blocks. 2D splines can be created directly in 3ds Max or imported from CAD applications such as AutoCAD. The main thing to remember is to have closed splines. This means that if you use the line tool to create a footprint, make sure it is a closed one. Otherwise, you can use other closed shapes from the standard or the extended spline list. For this example, use the angle shape. Since the building lots are slightly elevated, use the auto grid feature to make sure the spline is at the correct elevation. Click and drag to create a basic L shape, and then drag a bit more and click again to define the thickness. You can always fine-tune these dimensions later. Disable AutoGrid when done. Give the spline a rotation of 180 degrees in Z so you have a better look at the building's extensions, and zoom in for a better look. You are ready to extrude the shape, but you won't actually do it on the original spline, but on a duplicate. As you will see later, this gives you a lot more flexibility in the long run. With the spline selected, choose Edit, Clone, or press Ctrl V to access the Clone Options dialog. Choose the Reference option, and then click OK. Using Reference in this case is a major advantage as you can add modifiers to the duplicate without affecting the original spline. In this case, add an Extrude modifier to the duplicate shape and give it some value. Note the solid line that divides the base object from the Extrude modifier. Any changes or operations beneath that line affect all shared duplicates. Any modifiers over that line only affect the selected object. In this case, you added an Extrude modifier and you want the extrusion height to be dictated by the texture you need to apply. Open the Material Editor and create a new view called Buildings. Add an Arc and Design material. Drag out the Diffuse Column Map socket and choose Bitmap. Browse to the folder where you have stored the texture library and choose the file old brick 1 L1, width 9, height 4.6, diffuse JPEG. This is the same image you worked on in the last movie, and it represents a brick building street level texture. More importantly, the real-world dimensions are shown in the file name as 9 meters in width by 4.6 meters in height. Once you've added the bitmap to the material tree, double-click the bitmap node and enable the option Use Real-World Scale. Set the width and height accordingly, in this case 9 meters by 4.6 meters. Set the material to show in the viewport and apply it to the extruded shape. Nothing is shown yet, as you still need to define mapping coordinates. Unless your designs are inspired by the likes of Antoni Gaudi or Frank Gehry, simple architecture is typically mapped in box mode. This enables walls to be mapped using left, right, front, and back projections. Actually, that includes top and bottom projections as well, although you won't need those as far as walls are concerned. Add a UVW map modifier and set it to box mode. Instead of fiddling with the gizmo size, simply enable Real World Map Size so it reads the real dimensions you set at the bitmap level. If you need to, go to the gizmo level and adjust its Z position to adjust the floor level starting point. Exit that mode when done. Since the height of the picture is 4.6 meters in the real world, set the extrusion height to the same value. Also, you don't really need to see the top and bottom caps on this extruded volume, as they won't be seen at render time. You can therefore disable cap start and cap end, and thus reduce poly count even further. You're ready to move on to the next step, but before you do, add a reflection map to the material tree. Drag the reflection column map socket and add the bitmap old brick 1 L1 W9 H4.6 ref.jpg. Make sure you double-click its node and set its real-world dimensions to match the column map. If you want, collapse the material and make space for a new one for the upper floors. Save your file. In the next movie, you learn to automate certain tasks that make your work even easier.